Okay, so having solved for the dimensions of the first story, okay, of the first story, rectangular shape first story, we can now solve for the area of the second story. So how can we solve? Okay, so how can we solve? Okay, for the area. Okay, okay, how can we solve for the area of the second story? Okay, so this is the second story. So the first thing that we can do here is we can try to look for a clue. It says here that the second story's house is half the dimension. Is that right? That with the dimensions half of those of the first story's dimension here. So what we can do here, since we know the dimensions of the length, the dimensions of the first story rectangle, we know its length, which is 2 phi plus 4. Therefore, if you divide that by 2, okay, so you get p phi plus 2. So this is the length of the second story, and the width of the second story is going to be, okay, so it's going to be 5 plus 3 square root of 5 over 2. Okay, 5 plus 3 square root of 5 all over 2. Okay, so this is the width. Okay, and the length, okay, okay, so let's try to use this in terms of this one, 5 plus square root of 5. So the length is going to be, okay, so the length is going to be 5 plus square root of 5 all over 2. Okay, and from here we can now solve for the area. Okay, we can now solve for the area of the second story. So area of the second story is equal to 5. Okay, so the length is 5 plus square root of 5 all over 2. Okay, so 5 plus square root of 5 all over 2. Okay, hectometers multiplied by 5 plus 3 square root of 5 all over 2 hectometers. And the answer for that is equal to 10 plus 5 square root of 5 hectometers squared, or that's simply 21.18 hectometers squared. Okay, so that's the area of the second story of this house. Okay, and we've also solved for the width. Okay, and we've also solved for the perimeter, which is equal to this one, 20 plus 8 square root of 5 hectometers, or 37.89 hectometers. So for the second problem we have here, Mang Tonyo wants to create a draft for his mega rice field for his hometown province in Benguet, with the help of his relatives and closest friends and most loyal workers whom he considers family. Given that the length and the width of the rice field are 2p plus phi kilometers and 5p plus 3 phi kilometers, and the perimeter is equal to 161.80 kilometers. So we need to find the value of P, and also the area of the rice field, and also the diagonals IM and TU. Okay, so to solve first for the value of P, we can use the perimeter, the formula for the perimeter, since we're given here that the perimeter is equal to 161.8. Okay, so P is equal to 161.80. Okay, kilometers. So we can equate that as 2L plus 2P is equal to the perimeter. So that's going to be 2 times the length, which is 2P plus phi, plus 2 times 5P plus 3 phi. Okay, phi is the golden ratio, which is equal to 161.8. Okay, and from here we can simplify this equation in order to solve for the value of P. So this is going to be 2 times 2, so that's 4P plus 2 phi plus 2 times 5P, so that's going to be 10P plus 2 times 3 phi, so that's going to be 6 phi is equal to 161.8. And from here we can simplify much further. So we have here 14P plus 8 phi. Okay, 8 phi is equal to 161.8. From here we can transfer this constant to the other side. So this is going to be 14P is equal to 161.8 minus 8 phi. Okay, And if we divide both sides by 14, we're going to get the value of P. Okay, so P is equal to, okay, so P is equal to 10.63. Okay, so now that we solve for the value of P, we can now solve for the value of the diagonals. So how can we solve for the value of the diagonals? Given that the length here is 2P plus phi, and the width here is 5P plus 3Phi. Okay, what we can do here is we can substitute the value of P. Okay, so we can know the value of the length and the width. Okay, we also note that this is also 2P plus phi since this is a rectangle, and also we can take note that this opposite side is also congruent to the one that's at the bottom, so that's 5P plus 3Phi. Okay, so now we can solve for the diagonals, so we just need to substitute P for that. So the value of segment TM, okay, segment TM and IU is going to be 2P plus phi, and that's going to be 2 times 10.63 plus P plus phi, and that's going to be 22.88 kilometers. So for, okay, so we're finished with TM and IU. For IT and UM, since they are congruent and parallel to each other, or parallel and congruent to each other, so we can write here 5P plus 3Phi. So that's going to be 5 times 10.63, okay, plus 3Phi, and that'll give you a value of 58 kilometers. Okay, so now that we know the exact value of the length and the width, we can solve for the diagonal maybe a bit later, but for now let's try to solve for the area first, because we already have the givens for the length and the width. So the area of a rectangle is equal to the length times the width, so we've already found our length, so that's equal to 22.88, okay, 22.88 hectometers times the width, which is equal to 58, okay, 58 kilometers, I'm sorry, 22.88 kilometers and 58 kilometers. Therefore, the area of the mega rice field of Mang Tonyo is equal to, the area is equal to 1,327.04 squared kilometers. Okay, given that our length and width is 22.88 kilometers and 58 kilometers from the ones that we've solved a while ago. Okay, and now we can now solve for the value of the diagonals using the Pythagorean theorem. Okay, so how do we do that? Again, we already have the value of the length, which is 22.88 kilometers, and the width is equal to 58. Okay, so equal to 58 kilometers. Okay, so let's try to solve for the value of the diagonals UT and IM. Okay, so what are their values? We can check, or we can use the Pythagorean theorem. So we have here a squared plus b squared plus is equal to c squared. Since this is a right triangle, we have here 4 right triangles. But if we focus here on IUM and TMU, so we have here 2 right triangles, and therefore we can solve for the side measurement of, let's say, this one UT. Okay, by, let's say, finding first the length and the width of this one, and we've already found that. So the value of the length is equal to 22.88 kilometers squared plus the width, which is equal to 58 squared, is equal to c squared. And from here we can say that the value of c squared is equal to 3,887.49. And if we take the square root of both sides, we can get the value of c. The value of c is equal to 62.35 kilometers. Therefore, we've already solved for the value of diagonal, which is 62.35 kilometers, and also we've solved for the values of UT and IM since they are the diagonals of this rectangle. Okay, so the value of the diagonals is equal to 62.35 kilometers. And finally, guys, so we're going to prove the golden ratio. So we've been using this constant for so long, and we want to know how did we get that the value of phi is equal to 1 plus or minus, okay, 1 plus or minus the square root of 5 all over 2. And if you simplify that, so that's going to be 1.618, okay? So if that's plus, and 0.618 if that's a minus, okay? But we often use the plus, when we're dealing with the constants. And also the applications of the golden ratio, when you see the ratios in real life objects, it's always equal to, or always equal to 1.618 for the value of phi. Okay, so have you ever wondered where did this come from? So this is the symbol of it, and it's like made into gold to signify its golden status in mathematics and also in real life. So the one of the derivations, okay, so there are many derivations of the golden ratio, but one of which is the Fibonacci numbers. So it's discovered by a mathematician, an Italian mathematician, okay, so that was named from him. So his name was Fibonacci, and he has here this numbers that he's discovered the pattern from. So if you try to look for the pattern, it's going to be the sum, okay, or the okay, so if you add the numbers preceding before it, so there you go, you're going to get the number that's going to be next to it. So that's going to be 0 plus 1, you're going to get a 1. 1 plus 2, you're going to get a 3. 2 plus 3 is equal to 5. 5 plus 3 is equal to 8, so on and so forth until you reach positive infinity. Okay, so from this sequence of numbers, we're going to derive the value of phi, which is 1 plus or minus the square root of 5 all over 2, or 1.618 or 0.618. So let's check. Okay, so we have here the first part of our proof. Okay, so we have here the Fibonacci numbers. Okay, so if we are going to write a 2-column proof for that, so that's going to be a given. So we have here 0, 1, 1, 2, 3, 5, 8, so on and so forth. So Fibonacci numbers. And then from that, we can derive an equation. So x sub n, is going to be the number next in the pattern. Okay, so 5 x sub n, okay, dot x sub n. Okay, so it's the number that's going to be next in the pattern. So it's going to be the sum of x, okay, so it's going to be the sum of x sub n minus 1, which is 5, plus the sum of x sub n minus 2, which is 3. So it's the sum of the numbers before it and the number preceding the other number that was before the x sub n. Okay, so we have here this formula. X sub n is equal to x sub n minus 1 plus x sub n minus 2. And for any integer, a variable can represent an integer. Definition of the Fibonacci sequence. And from here, we can derive a ratio. We can derive a ratio from this given information that we have here. So x sub n all over x sub n minus 1 can be equal, okay, the ratios can be equal to x sub n minus 1 all over x sub n minus 2. So the ratio, okay, so if you're going to make it more concrete, so that's going to be if x sub n is 89, okay, so 89 all over 55 is going to be equal to 55 over 34. Okay, so this property holds true, so on and so forth throughout this proof. Okay, and also we can create a mathematical constant for that, and during the creation of this theorem or this equation, the mathematicians used a mathematical constant phi. But you can use other types of Greek letters. You can use alpha, delta, beta, gamma. Okay, so there you go. But the one that we use for this ratio is equal to phi. Okay, so from here we can see that we have here an x sub n. So this x sub n can be substituted, okay? If you look back at statement number 2, the value of x sub n is equal to x sub n minus 1 plus x sub n minus 2, this one. We can put this here at number 5. This is x sub n. So you have your x sub n minus 1 plus x sub n minus 2 is all over x sub n minus 1 is equal to the ratio that we have here. X sub n minus 1 is equal to x sub n minus 2. And this one simply, okay, when you divide that, when it cancels out and it gives you 1, okay,